Hi students, welcome to Math4U. Today we are going to discuss about real numbers from chapter 1. Before going deep into this chapter, let us see what are real numbers. So real numbers are numbers which are positive or negative, large or small, whole numbers or decimal numbers. So all these numbers are collectively, we can say that these are real numbers. So let us see the chart with examples. Okay, so real numbers, you can see here we have real numbers as a combination of rational as well as irrational numbers. You can see here rational numbers are given the examples negative 1 by 2, 1 by 2, 2 by 3, etc. So from this what you understood, you have already learned about rational numbers in the previous class in grade 9. So let us see what is rational number. You can see all these numbers are in the form of fraction, right? So rational numbers are numbers of the form P by Q, and one condition is that Q should not be equal to 0. That means the denominator should not be equal to 0. Okay, so now you can see here rational numbers given negative 1 by 2. This is of the form P by Q, right? All the numbers which is given of the form P by Q. So these are the examples of rational numbers. And this rational numbers includes integers, whole numbers, and natural numbers, right? And moving into it, you know that integers, negative numbers are there, positive numbers are also there, right? And in whole number, 0 is there, 1, 2, 3, etc. are whole numbers. And when moving towards natural numbers, we can see the positive integers, right? And all these are included in rational numbers. How can we say that these are all included in rational numbers? You can see here natural number, I am taking 3. So this is only having numerator now, right? So can we write this 3 in the form of 1 by 3 by 1? Yes. So this number 3 can be written in the form of 3 by 1. So now this is of the form P by Q, right? And now we can say that this is also included in a rational number, right? I'm taking this integer negative 2. Okay, so negative 2, we can write it in the form of negative 2 by 1. And now you can see that this is also of the form P by Q. So the thing is that all these integers, all number, natural numbers are all included in rational numbers, right? And as I told, the real number is a combination of rational as well as irrational numbers. So irrational numbers, you can see here root, this is not of the form P by Q, right? This is not of the form P by Q. That is the difference between rational and irrational numbers. So rational numbers are of the form P by Q. You can see here where Q should not be equal to 0. And irrational numbers are not in the form of P by Q. I hope it is clear to you. And now we are moving towards the main topic in this chapter, that is Euclid's division lemma. Before moving into the definition, let me explain to you with an example. Okay, so let us see as an example, we are going to divide two numbers, 13 divided by 2. We are using here the normal division method, 13 divided by 2. Okay, so we know 6 2s are 12 and we will get the remainder as 1, right? So here you know which is the dividend, divisor, quotient and remainder, right? You have already learned that. So I'm going to write here the dividend. So dividend is, which is the dividend here is 13, which is the divisor, you can see here 2 is the divisor, then quotient, I'm just writing Q, that is a 6 and the remainder is 1, right? So can we write this of the form 13, that is the dividend, that is equal to 2 multiplied with 6 plus 1, is that correct? Yes, very good. So 2 6 are 12 plus 1 is 13, right? And now can we write it as dividend is equal to divisor, so I'm writing it fully, divisor multiplied with quotient plus remainder. Is it correct? Yes. So we can say that a dividend is equal to divisor multiplied with quotient plus a remainder. Let me show you another one more example. So another one example is, let me divide here 275. Second example, 275 with 8. So as we have done earlier, I'm going to do it as normal division, 275 with 8. So you can see here 3 8s are 24, and we have the remainder 35, and 8 4s are 32, right? And we are getting here the remainder 3. So as we have done before, can we say that a dividend is here 275, divisor is 8, right? Quotient is 34, and the remainder is 3. So I'm going to write here 275 is equal to, can we say that 8 multiplied with, the quotient is 34 plus 3. Is that correct? Yes, 8 multiplied with 34 plus 3, you will get 275. So this means that you can say divisor, dividend is equal to divisor multiplied with the quotient plus remainder, right? So this is the condition what we obtained here. So now we are moving into the definition of Euclid's division lemma. So this is the definition. Given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where 0 less than or equal to r less than b. Okay, so what does it mean? We can take a and b as the two integers, that is the dividend and the divisor. Okay, so let us take the example what we have done in the first case. Okay, in the first case we got 13 is equal to 2 into 6 plus 1, and the second case I am copying it here, 275 is equal to 8 multiplied with 34 plus 3. These are the two conditions we got from two examples. Okay, so let us see here. So a and b are two positive integers. We are taking a as the dividend and b as the divisor. So I'm writing it over here along with the second example. A is the dividend and b is the divisor. So divisor is multiplied with the q. Q is the quotient over here plus r is a remainder. I hope it is clear for you now. So 0 less than or equal to r. So, okay. Here you can see that this is r should be greater than or equal to 0, and b should be anyway greater than 0. You can see here these all are greater than 0 here. Okay, so this is the condition here. So here you can say that a is equal to b multiplied with q plus r. Here also you can say a is equal to b multiplied with q plus r. So this is Euclid's division lemma. Okay, so here q and r are quotient and the remainder, a and b we have taken as the dividend and the divisor. Is that clear, all of you? So next topic is what we are going to do, the Euclid's division algorithm, where we will find out the HCF of two numbers. Okay, we will move on to that in the next class. I hope this much is very clear to you. Thank you.